The first stars were formed when hydrogen atoms collapsed from gravity. When the hydrogen cooled, this allowed the ordinary matter to contract, and these denser regions of gas contracted into star-forming clumps. Some of the clumps of gas collapsed to form very massive luminous stars. Most of these first stars were hundreds of times larger in the size and much brighter than the sun. When hydrogen and helium reach a certain point in temperature, greater than 15 million Kelvin, nuclear fusion occurs. Tritium and deuterium clash, creating fusion which results in 4 helium atoms and a neutron being created, resulting in the energy needed to make stars. Nuclear fusion going on in the core of stars is what allows them to output so much energy. Once iron becomes a big part of the core of the star is extremely close to its death. Life cycle of a low-mass star. Stars are first born in a nebula, then they go through their main sequence stage, the stage our sun is at right now, which makes up most of the star's life. After this, they turn into a red giant, which in our case will completely devour the Earth and kill any life on it. Following the red giant, the star will become a planetary nebula, resulting in a white dwarf, a small, very dense star, which is normally the size of a planet. At the very end of the low-mass star's life, it becomes a black dwarf, a sufficiently cooled white dwarf which doesn't emit any heat or light. Life cycle of a high-mass star. Like the low-mass star, high-mass stars are also born in nebulae. They spend most of their lives at the main sequence stage, also like the low-mass stars. Once a star runs out of hydrogen fuel in their core, they become a supergiant. If the star's iron core is massive enough, it collapses and becomes a supernova, which is a quick explosion that shoots out many of the elements we have on Earth. After a supernova, it may become a black hole or a neutron star, a dense ball of neutrons, denser than anything else in the universe.